Hi, this is Eric, and we're going to talk about how to do question 2a. So the first thing we always want to ask is, what do we want? We want to write the boundary conditions for x sub x, and we want to explain for full marks. So this is what we want. Always important to be able to know what you want. So the second thing is, what do we have? So we have an expression for u of x of t in terms of x and t. We have a differential equation. We might need that. We might not need that. We've got, all these different following solutions. But most importantly, we also have boundary conditions. And in particular, we have the boundary conditions are that the partial with respect to x is equal to 0 when x is equal to 0, and that the partial with respect to x is equal to 0 when x is equal to 1. So we want boundary conditions, and here we have two boundary conditions. So we know that u of x and t can be expressed using separation of variables as the product of two single variable functions. Now both of our boundary conditions involve the partial derivative of u with respect to x. So let's calculate partial derivative of u with respect to x. So this is a function of x and t. So this is going to be partial with respect to x of quantity x sub x t of t. Now the t part doesn't care about x, so that's just a constant. It's a product. It flows right on out of the derivative. And x is just a single variable function, so we're going to take the derivative of that. And so now we just want to evaluate this at our boundary conditions. So eval at BCs. Let's label those. We're going to call this boundary condition 1 up here and boundary condition 2, just so we don't get confused. All right, so let's evaluate boundary condition 1. What's going on here? So we've got x is equal to 0, so we've got x prime, x is equal to 0, and then t of t is equal to 0. And then for boundary condition 2, we've got x prime. Now this is occurring at x is equal to 1. Nice little parentheses there. T of t is equal to 0. So all we've done here is we've restated boundary condition 1 and boundary condition 2. Instead of in terms of u of x of t, we've used the separation of variables to express it in terms of our function capital X, and this turns out to be the derivative of that and the function capital T. And that's the correct answer. Now, in most cases, we're going to want to assume that t is some non-trivial function, that it's not 0. But that's not what this is asking. This actually has nothing to do with what particular differential equation we have. It's merely asking us to translate the boundary conditions from a two-dimensional function to the product of some one-dimensional functions. Now, common problems. The first one is not taking the derivative. Some people are so used to us setting the boundary conditions of that the function is 0 at 0 and the function is 0 at 1, they completely skipped over the fact that we're taking a derivative here for the boundary condition, we're taking the derivative here for boundary condition. Some of you might notice that we haven't actually fixed the value of the function at all with these boundary conditions. Just as a side comment, that's going to come up later on in the problem and be important. So the second problem that was quite common was that not taking the boundary conditions, taking boundary conditions at the right location. So many students solved for x0 is equal to 0 and x prime of 0 is equal to 0. This was not what we were looking for. So likewise, with the not taking of the derivative, people were looking at x0 is equal to 0 and x of 1 is equal to 0. Also not what we were looking for. Please read the problem. Know what you want, know what you have, and then connect them. 3 basic steps that we can use to help improve the chances that you'll get full marks on a problem. And if not full marks, then you know that your prayers to the gods of partial credit will hopefully not be in vain.